We're constantly hearing about how incredibly powerful AI is getting, right? It can write, it can create art, it can understand these really complex images in ways that, honestly, they seem almost magical. But what if I told you that even the most advanced AI has this shocking blind spot, a weakness so simple it's almost hard to believe? Well, we're about to dig into a new research paper that not only exposes this critical flaw, but also comes up with a brilliant solution.
All right, let's just jump right in. To really get a handle on the problem, researchers put the world's top AI models through what seems like a ridiculously simple test. And the results? Well, they're pretty mind-blowing.
Okay, so get this. This chart shows something that's just wild. Researchers gave AI a super simple task. They took an image, they either rotated it or flipped it, and then they just asked the AI what happened. It's a multiple choice question. Now, you or I, we'd get this right 100% of the time, no problem. But look at these models. Even the heavy hitters like GPT-5 and Gemini, they score barely better than if they were just guessing randomly. We're talking about a fundamental failure at a task a little kid could do in a heartbeat. And let me be clear, this isn't just some funny party trick. The research shows that these simple little tweaks, just flipping a photo, can cause their performance on other, more complex tasks to plummet by up to 80%. It just reveals this shocking brittleness in how these systems actually understand the visual world around them.
So, why? Right? That's the big question. Why does a multi-billion-dollar AI get so completely confused by a picture that's just a little bit sideways? Well, the problem, as it turns out, is all about how AIs are taught to see using a pretty limited set of tools. So right now, most AIs basically have this fixed toolbox. They might have a crop tool or a tool to read text, but that whole approach is just incredibly rigid. The tools are all handcrafted, they don't scale well, and this is the most important part, the AI is just terrible at combining them to solve tricky problems that need more than one step. It's kind of like trying to build an entire house with nothing but a hammer.
This right here, this is the perfect way to think about the conceptual leap we need to make. It's the difference between giving a chef, say, just a knife and a spoon, versus teaching them metallurgy so they can literally forge any tool they could ever possibly need. One way is limited and inflexible. The other is infinitely powerful. And that brings us to the really cool solution that this paper proposes. It's a new framework, and they call it CodeVision. The idea behind it is so simple, but it's also profound. Instead of giving an AI a fixed set of tools, you teach it how to code. So by treating code like this universal interface, the AI is suddenly not limited to some pre-approved list of actions. It can generate its own Python code right on the fly to do any image operation you can think of. You want to rotate, crop, and increase the contrast all at once? The AI doesn't need to ask for 3 different tools. It just writes the code to get it done. Now, this whole code as a tool approach unlocks 3 amazing new abilities. First, you get emergence. That means the AI can literally discover new tools it was never, ever taught. Second, it creates incredible efficiency because it can chain a bunch of operations into one single smooth step. And third, it builds robustness, so it can actually look at the results of its own code, see its mistakes, and then fix them. But okay, that's the big question, right? How in the world do you teach an AI to think like a programmer when it's looking at pictures? It's not as simple as just, feeding it a library of code. The researchers came up with this really clever 2-stage process. First up is what's called supervised fine-tuning. You can think of this as sending the AI to coding school. It studies a really high-quality data set to learn all the basic syntax and patterns. Then comes the second phase, reinforcement learning. And this is like its first real-world job. This is where the AI learns how to strategize, how to make smart decisions, and how to solve problems efficiently. But here's the real secret sauce, the reward system. See, the AI doesn't just get a cookie for getting the right answer, it gets rewarded for choosing the smart path, for using the right strategy, for discovering brand new tools. And it gets penalized for taking the lazy brute force approach, like just trying every single tool to see what sticks. This forces it to actually think strategically, not just get lucky. Okay, so the theory sounds amazing, but does it actually work? Well, the results from putting this new approach to the test show just how powerful it really is. The results are, well, they're nothing short of dramatic. On a brand new benchmark that was designed specifically to test this complex multi-tool kind of reasoning, the CodeVision model doesn't just do a little bit better, it almost doubles the score of the next best model out there. We're talking a massive leap forward in capability. But here is where it gets really, really cool.
Remember that whole idea of emergence? This word cloud shows you tools that the CodeVision model started using all on its own, tools that were never in its training data. It taught itself about brightness, contrast, sharpening, even edge detection, all by itself, simply because it realized they were useful for solving problems.
And this right here is that emergent ability in action. So the AI is asked to count the words in a really dark, low-quality photo. Instead of just guessing, it reasons that the image is hard to read. So what does it do? It spontaneously writes code to convert the picture to grayscale and jack up the contrast before it even tries to count the words. That is a whole new level of visual reasoning.
And here we see that incredible efficiency. To answer a simple question about a rotated image, the model writes one single block of code that performs 5 different operations, one after another. It rotates the image, it boosts the contrast, it increases brightness and sharpness, and then it crops the right area. And get this, 3 of those 5 tools were ones it discovered all by itself. An older model would have needed 5 separate turns just to even attempt something like this.
You know, a truly intelligent system isn't one that never makes a mistake. It's one that can recognize its mistakes and then learn from them. So how does CodeVision handle it when it messes up?
This is that robustness in action. So on the left, the model sees an inverted image and it incorrectly thinks, oh, I need to rotate it. So it writes the code, it runs it, and it gets the new image back as feedback. It can literally see that its own action didn't work. So in the very next turn, it reevaluates and says, okay, that was wrong. Let me try cropping instead. It gets direct feedback from its own code and it course corrects.
And check out this even more sophisticated example. The AI is facing a really tricky image that's both mirrored and flipped. So it just methodically tests different ideas. It's like, okay, first let's try a horizontal flip. Nope, still unreadable. All right, how about a vertical flip? Still no good. Finally, it tries a 180-degree rotation, and that works. It's using this logical trial and error process, just like a person would, to solve the puzzle.
So let's zoom out and look at the bigger picture here. Because this breakthrough, it's not just about fixing sideways photos. This really points to the future of what visual AI is going to be.
What we're really seeing here is a fundamental shift in thinking. We're moving away from AI that just passively describes an image to an AI that can actively interact with and manipulate the visual world. It's treating vision itself like a programming task, and that opens the door for way more robust and flexible AI agents. And that leaves us with this one final fascinating question. Teaching an AI to see, that was the first big step. Now we're teaching it how to program its own vision. It can invent its own tools, it can test its own ideas, and it can learn from its own mistakes. So if an AI can truly think with images, what will it be able to see and do next?